Started. 7.2, multiplying polynomials. Friday, we added and subtracted, corrected? Correct? Correct. We added and subtracted? Okay. Today we're going to multiply polynomials. Write this down. FOIL. FOIL. Shh, we shouldn't be talking. We should be writing. Yeah, that'd probably be good. It's an example. Notes are full of examples today.
Hopefully a lot too. Can you sing happy birthday to Papa? I did.
Okay. I got a polynomial times a polynomial here, correct? X plus 2 times x plus 3. What kinds of polynomials are these? What would I call them?
Foil.
Binomials. Why are they called binomials?
Because it's two problems.
Because they each have two terms. What are the two terms in this polynomial? X and 2. What are the two terms over here?
X and 3.
X and 3. So these are binomials, right? Two terms. Means it's a binomial like a bicycle has two wheels. Everyone okay with that? Okay, so when I'm multiplying polynomials, I need to make sure every term in the first polynomial gets multiplied by every term in the second polynomial. Everyone understand that? So every term over here, x and 2, has to get multiplied by every term over here, x and 3. Okay? Whenever we have a binomial times a binomial, the acronym FOIL helps us do that. Helps us multiply every term by every term. Okay? So F stands for first. Write that down. So what's the first term of my first binomial? X. What's the first term of my second binomial? X. So I'm multiplying the first term of each binomial. So what is x times x?
1.
X squared. Remember when we're multiplying something with the same base, I add the exponents. What exponent does each of those x's have?
2.
1. 1 plus 1 gives me 2. That's how I get x squared. Does that make sense? X times x gives me x squared. O stands for outer. Now we're looking at the product as a whole. As a whole, okay? Not individually, binomials. Just as a whole, we're looking at the product. What are the two outer terms? The two things on the outside of my two binomials? X and 3, right? Those are the two outer terms. Does everyone see how those are outer? We're not looking outside the parentheses. I'm just looking on the very outside of the product as a whole. Okay? Does everyone see how it's x and 3? So now I'm multiplying the outer terms. What's x times 3?
3x.
3x. Questions on that?
No.
If O stands for outer, what does I stand for? Inner. Inner. Not enter. Inner.
Oh, inner, not inter.
So what are my two inner terms on the inside of my product? 2 and x. I'm going to multiply 2 times x. What is 2 times x? 2x. Everyone okay with that? Does everyone see how 2 and x are on the inside of the product? Okay? And if F stands for first, L stands for last. So now I'm looking at the binomials individually now. What are the last terms of each binomial?
3 and 2.
2 and 3. What's 2 times 3? 6. Has every term in my first set of parentheses now been multiplied by every term in my second set? Yep, so I'm done with my multiplication. So everyone see how we did that? Now, I need to see if I can combine any like terms. Do I have like terms? 3x and 2x. What is 3x plus 2x? 5x. So I get x squared plus 5x plus 6. Do I have any other like terms to combine here?
No.
No. Is this in standard form?
Yes.
What is standard form again?
Biggest exponent. Small.
Yep. My exponents are decreasing from left to right. Starts with the biggest, gets gradually smaller one by one, little by little.
Well, yeah.
So I do want your answers in standard form. There's my answer. Does everyone understand how we got first, outer, inner, last? Everyone okay with that? Yep.
X squared is just, or maybe it isn't.
Do what? You good? Yep.
Will there be anything bigger than a trinomial?
Say it again.
Will there be anything bigger than like a trinomial where there's...
You could get that, but for today, we'll see binomials and trinomials. Okay? Can I move on? Shh, too much talking going on. Some examples here. First one's x plus 2 times x plus 5. Everyone has FOIL written down on their paper, so I don't have to write it down, correct?
Correct.
Okay. Do I have a binomial times a binomial? Yes, so I can use FOIL. If I have anything bigger than a binomial times a binomial, I can't use FOIL.
Right.
Okay? So, F stands for what?
First.
First, what are my first terms?
X and X.
So what's x times x?
X.
X squared. Okay, I got onto my other classes for saying that. Don't worry, it's not just you guys. There's a lot of people in all my classes that say it as x2. It is not x2.
My bad.
It is x squared or x to the second power. So I want you to say that from now on.
Okay.
Don't say x2, x3, x5, 4x2, anything like that.
A.
How would I read that off?
F of X.
F of x. Not f times x, not fx, f of x. Okay, I want you guys to say things correctly in here.
Okay.
Okay? Okay, back to our problem. X times x is
X squared.
x squared. There we go. What does the O stand for on FOIL?
Outer.
Outer. What are my outer terms here? X and 5. What's x times 5? 5x. Okay there.
Yeah.
What does the I stand for?
Inner.
Inner. What are my inner terms?
2 and X.
What's 2 times x?
X. 2. 2X.
2x. And what does L stand for?
Last.
Last. What are my last terms?
5 and 2.
What's 5 times 2?
6.
10.
What?
6.
Okay, first of all. 5 plus 2.
5 times 2.
Oh.
5 plus 2 is 7. Okay. Has every term... Shh. Has every term in the first set of parentheses been multiplied by every term in the second set?
Yeah.
Yep. Now I can see if I need to combine like terms. Do I?
Yes. 5x and 2x.
What is 5x plus 2x?
5x.
7x.
Oh my gosh.
Any other like terms?
No.
Any other like terms?
No.
No. Is this in standard form?
Yes.
Yes, it is. Questions on that first one?
No.
We good with that?
Yeah.
Now, there is another way we could look at it. I'm a big fan of FOIL. I think it works really well. It's easy to understand, easy to remember, right? You guys in biology right now?
Yeah.
You guys dealing with Punnett squares?
Yeah.
Yeah, Punnett squares.
Oh, yeah. I want those.
So you can put your... You can make a Punnett square with your binomials. And you guys know how Punnett squares work, right? I go down from the top, over from the left, and where they meet, I multiply, right? So here I got x times x, which is
2
x squared.
x squared.
2 times x would give me 2x.
Yeah.
X times 5 would give me 5x. 2 times 5 would give me 10. This is called the box method. And then from there, you got all your terms. You can start combining like terms if you have any. I don't have any other x squareds. I got like terms here with the x's. And I don't have any constants besides 10. So, you can use that method if you'd like. To me, it takes a little more time because you got to draw your Punnett square and stuff. I'm a big fan of FOIL. But if you like this method, that makes sense to you, go for it.
They both make
Okay? Questions on the first one?
No, sorry.
Can I erase and move on?
Yeah.
Okay, this next one, I'm going to start to move a little quicker since we're kind of getting the hang of it, okay?
Okay.
Like I said, I'm going to move a little faster. I'm not going to ask you what FOIL stands for each time. I'm just going to say, what are my first terms? So what are my first terms here?
X and X squared.
X times X is?
X squared.
X squared. Outer terms.
3 X and 4.
X to negative 4. What's X times negative 4?
Negative 4X.
Negative 4X. Inner terms.
3 and X.
3 times X. 3X. Last terms.
3 and 4.
3 times negative 4.
Negative 12.
Negative 12. We okay there?
Yep.
Combining like terms. What's negative 4X plus 3X?
Negative 1x.
Negative 1X or negative X.
X.
So I get X squared minus X minus 12. Do I have any other like terms?
No.
What'd you say?
They need to watch a movie.
Okay. Is this in standard form?
Yes.
Yeah, it is. There's my answer. Questions on the second one?
Nope.
We good so far still?
Yep.
Feeling good?
Mm-hmm.
Now, if you've noticed, there's kind of a trend going on here. This is just distributive property being used multiple times, right?
Yep.
I distribute my first term all the way through that second set of parentheses. I distribute my second term all the way through that second set of parentheses. Right?
Yeah.
That's all it is. If I had 3 terms in the first set of parentheses, I'd be doing 3 sets of distributive property. If I had 4 terms, I'd be doing 4 sets of distributive property. It's just multiple distributive properties. Does that make sense?
Right.
We good with that? We all understand distributive property, right?
Of course.
Good. Okay, next one on this slide, 2x minus 3 times x plus 5. What are my first terms?
2X and X.
Okay, what is 2x times x?
X. I mean 2X.
2x squared.
2X.
Remember, you got to multiply the coefficients. So what's 2 times 1?
2.
2. Whenever we're multiplying something with the same base, I do what with the exponents? Add them. So I got 1 plus 1, which gives me.
2.
So that's how I get 2x squared.
Okay.
What are my outer terms?
That's
So what's 2x times 5?
10.
10x. Inner terms?
2X and 5. Oh. X.
Inner terms?
Negative 3 and X.
Negative 3 and x. What's negative 3 times x?
Negative 3X.
Negative 3x. Last terms?
3 and 5.
Negative 3 and 5, which gives me
Gives you
negative
negative
15. I can combine like terms. What's 10x minus 3x?
7X.
7x. So I get 2x squared plus 7x minus 15. Is that my final answer?
Yeah.
Yes, it is.
Where's the 7 group?
10x minus 3x.
Oh.
Combining those like terms. What? You got a question? Okay. Any other questions on this slide?
No.
We're still good. We're still getting it.
Mhm.
Pretty easy?
It's gonna get harder than this, ain't it?
Pretty easy?
Yeah.
Okay, can I move on?
Yeah.
Here we go. More examples.
Okay.
Real quickly through this first one. This one's pretty easy.
Yeah.
What's x times x?
2x squared. I mean x squared.
X squared. X times negative 6.
Negative 6x.
Negative 6x. Negative 3 times x.
Negative 3x.
Negative 3x. Negative 3 times negative 6.
18.
Positive 18.
See, I know I know.
Combining my like terms, what's negative 6x minus 3x?
Negative 3x. Whoa, that's not.
Negative 9x.
Negative 9x.
And is that my final?
Yo.
There's my answer. Good there.
No. Yeah.
Okay. Next one. What are my first terms in this case? 2x plus 1 times 3x minus 5.
2x. And 3x.
2x and 3x. So 2x times 3x gives me 6x squared. Very good. Once again, you got to multiply those coefficients. 2 times 3 gives me 6. And each x has an exponent of 1, so 1 plus 1 gives me 2. So that's how I get 6x squared. What are my outer terms?
5 and 2x.
2x and negative 5, which gives me
Negative 10x.
negative 10x. My inner terms,
1 and 3.
1 and 3x. What does that give me?
3x.
3x. And my last terms,
1 and negative 5.
1 and negative 5, which gives me
5.
negative 5. 1 times negative 5?
5.
Negative 5. What do I get for my final answer? Someone raise your hand and tell me.
Okay, well, 6x squared. Take away 13x.
7x minus 5.
Should have called him. But that. Oh.
Negative 10x plus 3x would give me negative 7x. There is my final. We okay with that?
Yeah.
What are we confused about? See some people erasing, see some people being confused. Do we just not know how to add negative 10x and 3x?
I just tried to put the exponent.
Oh, okay. Questions on that one?
No.
Okay, next one on this slide. What are my first terms?
N and N.
N and N squared. So I'm doing N times N squared. What does that give me?
And
N
N cubed into the third power.
cubed.
Because what exponent does this N have?
2.
1. If I'm multiplying something with the same base, add the exponents. What's 1 plus 2?
3.
That's how I get N cubed. And we got that.
Oh, so it don't, okay.
We're good with that.
Yeah.
Okay, what are my outer terms?
and 3.
N and 3. What is N times 3?
3N.
3N. What are my inner terms?
2N squared.
2 and N squared. What's 2 times N squared? 2N squared. My last terms.
2 and 3.
2 times 3.
5.
6.
Wait, you're not adding.
Times. We're multiplying these, right? Distributive property, we multiply, right?
Right.
Right. Question. Yeah.
How'd you get the last one?
2 times 3.
Where do you see 2 times?
Yeah, you remember L on FOIL stands for last, right?
Oh, okay, I was looking at the wrong one.
Okay. Okay. Do I have any like terms here? I do?
Yes.
Where?
2 and
Oh,
squared.
wait, never mind. No. No, you don't.
3 and 2
Oh,
and
you just
squared.
gotta put it in.
Remember, when I'm adding, subtracting like terms, I can only combine N cubes with N cubes, right?
Yep.
So do I have any other N cubes?
No.
No. I can only combine N's with N's. Do I have any other N's besides the 3N?
No.
No. I can only combine N squareds with N squareds. Do I have any other N squareds besides 2N squared?
No.
No. I can only combine constants with constants. Do I have any other constants besides 6?
No.
No. So do I have any like terms to combine here?
No.
Shouldn't be talking while I'm talking. Okay, so no like terms to combine. Is this in standard form?
No,
Why not?
because it's 3120.
What?
Because it's 3120.
Oh yeah, my exponents aren't decreasing from left to right, are they?
No.
So how would I write this to get it in standard form?
N3
N cubed, because that's my biggest exponent.
cubed.
Hmm?
N plus N2.
Not N2.
N2 N 2N squared
2N squared
plus 3N
plus 3N
plus 6.
plus 6. Is that now in standard form?
Yes.
Yep. Exponents are now decreasing from left to right. Are there any questions about any of these examples on this slide?
No.
We okay with those?
Yes. Didn't we
Make sure you're paying attention if you got a different exponent here, so you know what you're multiplying by. Okay?
Didn't we do this last week?
This is addition, I think.
Do what?
Didn't we do this last week?
We did this when we talked about conjugates. If you guys remember multiplying our conjugates out, multiplied every term on the first side by every term on the second side, but we had a little shortcut. Here we don't have a shortcut because I don't have anything canceling out. Can I move on?
Yeah.
Here we go.
Uh-oh. That's big.
All our previous examples were binomials times binomials, correct?
Yep.
What do I have here?
Binomial to multiply by a trinomial.
Or a binomial times a trinomial. X plus 5 times x squared minus 3x minus 2.
I do. Too easy.
Do you think I can use FOIL here?
No,
Why not?
because it's not binomial times binomial.
It's not a binomial times a binomial. But more specifically, I have more terms than what I would have letters in my acronym. FOIL only fits a binomial times a binomial. Okay? But I've got 5 terms here instead of 4 terms, right? So, or however, the process does not change at all. It's still the same concept. Every term in my first set of parentheses gets multiplied by every term in my second set of parentheses. So I'm still doing the same exact thing. Okay? So I'm going to take my x, multiply it all the way through that second set of parentheses, and take my 5, multiply it all the way through.
Can you just do like x times each one and then 5 times each one?
That's what we're doing.
But so why is it complicated order?
Say what?
Like complicated order. Why don't you just do x times x to the second, x times?
That's what we're doing.
But is there a certain order you gotta go in?
No, because in the end we're going to put it in standard form.
So it don't matter.
So you
No,
don't even
you can do the 5 first if you want, or
You don't even have to use FOIL. You could just go x to like whatever and multiply it by the other ones.
well, that's what FOIL's doing.
Can we still use the
Oh, yeah.
square?
Doing that exact same thing that you're explaining to me right now. Okay? Do what?
Can we still use the square?
Yeah, I'll show you that here in just a second after we do the...
Rectangle.
Yeah. So let's take our x, multiply it all the way through. What's x times x squared? X cubed. X times negative 3x. Nope. Nope. Negative 3x squared. X times negative 2. Negative 2x. So I've distributed my x all the way through the parentheses, right? Which is what you were telling me to do, right? Now I got to multiply my 5 all the way through. 5 times x squared. 5x squared. 5 times negative 3x. Negative 15x. 5 times negative 2. Negative 10. Has every term in my first set of parentheses been multiplied by every term in my second set?
Yeah.
Yep. So I'm done multiplying. Now I just got to go through, combine like terms, put it into standard form as I go. Okay? What's my biggest exponent here? 3, so x cubed. Do I have any other x cubes? No, so I just bring it down. What's the next biggest exponent?
2x.
2. So I have negative 3x squared. Do I have any other x squareds? 5x squared. What's negative 3x squared plus 5x squared? 2x squared. Done with those terms. What's my next biggest exponent?
Negative 2x and negative 15x.
Negative 2x and negative 15x. What's negative 2 minus 15?
15x.
Negative 17x. Do I have any other constants besides negative 10? No. Any confusion on what I've done? Any other like terms I can combine?
No.
No. Is this in standard form?
Yes.
Yes, it is.
But how is it in standard form?
Because it's decreasing 3 to 2 and then.
Yeah, my exponents are decreasing from left to right.
Wait, what?
Exponents are decreasing from left to right.
Oh, so it just has to be the exponent.
Yeah.
It doesn't have to be the actual number.
The coefficient? Yeah, no.
Okay,
Yeah, we're just looking at the exponents for standard form.
so
And then
like-
whatever coefficient's there is just there with it.
Okay.
Okay? Questions on binomial multiplied by trinomial? Now, like we said earlier, you could do the box method. You just have more boxes than you would than a binomial times a binomial. So I'd have x plus 5 Then I'd have x squared, a negative 3x, a negative 2. And now I'm just still multiplying where they meet. So x times x squared is x cubed. 5 times x squared is 5x squared. X times negative 3x is negative 3x squared. 5 times negative 3x is negative 15x. X times negative 2 is negative 2x. 5 times negative 2 is negative 10. I only have one x cubed. Got like terms here. That'd give me 2x squared. Got like terms here. Give me the negative 17x and minus 10. So you can use the box method and you get the same answer. Got that, Noah?
Yep.
Make sure heads are up, please. There's the box method for you.
The box method's easier.
You think so? Yeah, if you want to do the box method, go for it. Yep.
So then the box method can be used with any, like, polynomial?
Yep. I could do a trinomial times a trinomial. Trinomial times a polynomial of 4 terms. You name it. The first polynomial will determine how many columns you have. This is a binomial, so I got 2 columns. Second one will determine how many rows you have. It's a trinomial, I got 3 rows. Or vice versa. I could have I could have put my trinomial up top, my binomial down the side. Could have done it either way. Questions on binomial multiplied by trinomial? We good? Moving on. Dun, dun, dun. Don't worry, this is easy.
No.
This is easy. I'd write this down. This part of the chart down. So we've talked about addition, subtraction, multiplication with polynomials, correct?
No.
Yes, we have. Friday and today. That's all we've done. So on some problems, it may give you 2 functions, f and g, or 2 other functions. And then it would tell you, hey, using these 2 functions, find f plus g of x. That's how you would read that one, f plus g of x. Everyone say it with me. F plus g of x. Say it again. F plus g of x. Say it again. F plus g of x. Let's say it again. F plus g of x. Everyone got it? If it's written like this, I just need you to know that that's just telling me to, hey, add f of x plus g of x. That's all it means. F plus g of x equals f of x plus g of x.
Yes, sir.
F plus g of x equals f of x plus g of x. Same thing for f minus g of x. F of x minus g of x. And f times g of x, f of x times g of x. Everyone got that written down?
No.
Hurry up. Still the same operations we've been talking about Friday and today. They just look a little different now, but we still use the same processes. How do I add functions or polynomials? How do I add polynomials? It's a 3-word phrase. The words start with C, L, and T.
Correlation.
No. C, L, T. There you go. Combine like terms. That's all I have to do to add polynomials, right? Just combine your like terms. How do I subtract polynomials?
Oh my gosh.
Subtract like terms.
Essentially, yeah. You got to distribute that negative first, and then you can just combine like terms, right? Distribute that negative to that second set of parentheses, combine like terms. And then multiplication is what we talked about today. Every term in the first set of parentheses gets multiplied by every term in the second set of parentheses. Questions about any of that? Okay, let's move on. Okay, here we go. It gives us 2 functions. It says let f of x equal 3x squared plus 5x minus 2, and g of x equal x squared minus 4x plus 6. Letter A wants me to find f plus g of x. So like I told you, it's going to give you two functions, f of x, g of x. It's going to want you to find f plus g of x. Okay, based on my previous slide, how was I able to rewrite f plus g of x?
X plus g of x equals fx plus g of x.
Not fx,
F
f of x plus
g of x.
g of x. There we go.
Wait,
F plus g of x equals f of x plus g of x, right?
I know, but
Okay. Now hold on, we're not done. We're not done. What is my f of x function?
3x squared plus 5x minus 2.
3x squared plus 5x minus 2. So I'm just going to plug this stuff in for f of x.
wait, my bad.
I just replaced f of x with the function that it equals. Okay? Plus, what does my g of x function equal?
X squared minus 4x plus 6.
X squared minus 4x plus 6. I just took whatever f of x equaled, plugged it in for f of x. Whatever g of x equaled, plugged that in for g of x. Now I've got a polynomial plus a polynomial, and now I can do that operation. Okay? So now I'm just combining like terms. What's 3x squared plus x squared? 4x squared. What's 5x plus negative 4x? X and negative 2 plus 6. Positive 4. Do I have any other like terms I can combine? No. Is this in standard form? Yeah. Here is f plus g of x. Everyone got that? So essentially you're just plugging your functions in and doing whatever operation is there. Here was addition, so I added the two polynomials. Questions on A? Questions on A? What are you confused about? Okay, erasing and moving to B. Letter B wants me to find f minus g of x. How else can I write f minus g of x? F of x minus g of x.
Why do we use f and g?
That's just the two main ones, the most common ones that people use. You can use h of x, t of x, r of x.
I get like function, but I don't know where g comes from.
It's just another variable to describe another function. Because it'd be confusing if you use f of x minus f of x, you know what I mean?
I don't know if I should use x because it looks like a multiplication thing.
This is just function notation, which we talked about earlier in the year, right?
Yeah,
So, we already said f of x
that's here, not here.
was 3x squared plus 5x minus 2. I'm now subtracting the two functions, so minus x squared minus 4x plus 6. I just replaced f of x with what it equals, replaced g of x with what it equals. Right? Does that part make sense? Question.
So will now you subtract it now?
Yeah, now we're subtracting because it wants me to find f minus g of x.
Will you divide it?
No. You'll deal with rational functions in Algebra 2, which is dividing polynomials, essentially. Okay, what's special about subtraction that I need to do first?
You need to distribute a -1.
Distribute my negative 1 through that set of parentheses. Does anything change about my first set? Not right now. What's happening to all the signs in this set of parentheses if I'm multiplying by negative 1? Just changing all the signs. So positive x squared becomes negative x squared. Negative 4x becomes positive 4x. Positive 6 becomes negative 6. Any confusion? Slowing down. What am I able to do after I distribute that negative? Yeah, now I can start combining like terms. So I got 3x squared minus x squared, which would give me 2x squared. I'm done with those two terms. I've got a 5x plus 4x. What does that give me? 9x. I'm done with those two terms. Got a negative 2 minus 6, which gives me negative 8. Any other like terms to combine? No. Is that standard form? Yep. This is f minus g of x. We good with that? So this is just combining Friday and today. It just gives you two functions. You got to plug them in, and then you're just doing the operations we did Friday. Addition and subtraction. We good? And then you can do the same thing with multiplication. It gives us two functions. F of x equals x minus 4. G of x equals 2x squared plus x minus 3. And it wants me to find f times g of x. F times g of x. Which how else could I write f times g of x? F of x times g of x. You okay with that? Any questions so far? We're still good? Still making sense? Okay, so now what does f of x equal here? X minus 4. So I replace f of x with x minus 4. And then what does g of x equal?
2x squared plus x minus 3.
2x squared plus x minus 3. So I can replace g of x with that polynomial. And now this is just a problem that I've seen today in class. Just multiplying these two polynomials, right? So every term in my first set of parentheses gets multiplied by every term in my second set. Distributing twice. So I need to distribute my x first. What's x times 2x squared? 2x cubed. X times x. X squared. X times negative 3. Negative 3x. So x has now been multiplied by every term in that second set of parentheses. Now I need to multiply my negative 4 through. Distribute it. It's negative 4 times 2x squared. Negative 8x squared. Negative 4 times x. Negative 4x. Negative 4 times negative 3. Positive 12. Okay, now that I've multiplied every term for my first set of parentheses by every term in my second set, what do I do now? Combine my like terms. Do I have any other x cubes? No, so this just comes down by itself. Do I have any other x squareds? Negative 8x squared. X squared minus 8x squared gives me negative 7x squared. Do I have any other x's besides negative 3x? Negative 4x. What's negative 3x minus 4x? Negative 7x. Do I have any other constants besides 12? No. Any other like terms to combine? Is this standard form? Yeah, is this my final answer? Yep. Questions on this example? 2x cubed minus 7x squared minus 7x plus 12 is f times g of x. We good? I know there's a lot of examples, but did it all make sense as we were doing it? We were getting the hang of multiplying our polynomials by polynomials. Just make sure every term in your first set of parentheses gets multiplied by every term in that second set. Distribute every one of those terms to that second set of parentheses. We good? Okay, we'll get the assignment tomorrow.